This is just a set of true-false statements. Can we identify them as true or false? As I stated in another video, stronger intermolecular forces for a molecule means that it's going to have a higher boiling point. The reason is because if I've got a molecule that has very strong intermolecular forces, it's going to stick very intensely to other molecules of itself, and therefore it's going to require more heat to get those molecules to separate and convert from a liquid into a gas, that is, to boil. So stronger intermolecular forces, higher boiling point. Now, that's inversely related to vapor pressure. Higher boiling point and stronger intermolecular forces means lower vapor pressure. The reason is because vapor pressure is the amount of pressure that a liquid exerts on the atmosphere. So liquids actually push up on the atmosphere. If you've got a liquid where all the molecules are sticking together very intensely, high boiling point, they are not going to want to escape very readily and push up towards the atmosphere. They're going to stay put. So once again, higher boiling point, stronger intermolecular forces, lower vapor pressure. Now we look at these two molecules, carbon tetrabromide and carbon tetrachloride. You should recognize from the explanation that I gave earlier involving the truck question, I'll link to it here, that carbon tetrabromide and carbon tetrachloride are both very, very non-polar. That means that the only real intermolecular forces that they're going to have are London forces, which are very weak. That brings us to this statement. Carbon tetrabromide has weaker intermolecular forces than carbon tetrachloride. Is that true or false? Well, as it turns out, that is false, because they both have the same types of intermolecular forces, just London forces. So they have equally weak / sucky intermolecular forces. Now let's look at this. Carbon tetrabromide is more volatile than carbon tetrachloride? Well, the way to answer that is ultimately to answer part B. Is carbon tetrachloride have a higher boiling point than carbon tetrachloride? You might remember from another video, and I'll link to it here, that when you have two molecules that have the same kinds of intermolecular forces, such as London forces in these two molecules' case, the only way you can tell the difference between boiling points is going to be size. If all other things are equal, the larger molecular weight is going to have a larger boiling point. So that means that carbon tetrabromide is going to have a higher boiling point than carbon tetrachloride. So that statement is true. So that should answer statement A for you, based on what I put up here. Carbon tetrabromide down here has a higher vapor pressure. Yeah, this should also answer statement D for you down here, based on the interrelationship that I've got up top.